First, I would also like to thank Prasad and OEM for organizing this webinar. And secondly, I would like to thank everybody who is currently in attendance and who will be joining us later on. I know that COVID-19 has affected us in more ways than we can imagine, and I appreciate you guys taking the time out to be here to talk about Industry 4.0 and to understand its limitations and its implications as well. As Prasad has already pointed out, I am an associate professor, or as in my university, the terminology goes, a reader in digital manufacturing. So what I will be doing is I will be going through my knowledge and my research activities with regards to Industry 4.0 so that you can get an idea of what is in store for you. But before I begin, I would just like to highlight one aspect. It is not like Industry 4.0 just started to gain steam. This was a hugely important aspect even before COVID-19 struck us. And this pandemic has only accelerated the adoption of Industry 4.0. So it is not like pandemic happened and boom, everybody wants to go digital. So this has been brewing for quite a while. Industry 4.0 is also terminalized as the fourth industrial revolution. That's why 4.0 goes there. It is also known as the digitization of manufacturing. So it goes by very many names, as you can imagine. Interestingly, even to this day, we do not have a specified definition for Industry 4.0. Different researchers, different organizations, different governments even define Industry 4.0 in different terminologies. So I will be briefly touching upon that. So what I want to highlight before I start off with the webinar is the fact that Industry 4.0 is not a one shoe fit all size kind of a thing. It is not something that you will install in your facilities and you will immediately get the benefits. It requires a systematic approach towards not only adoption, but implementation as well. One of the biggest hurdles is the fact that there are no standardized approaches as to how a company or an organization should implement Industry 4.0. So that is a very common deterrent for organizations because they just don't know how to go about it. Is Industry 4.0 beneficial for you? Absolutely. Is it something that you should aspire to get to? Absolutely. But will it solve your problems very, very quickly and give you a return on investment very, very quickly? That is not a straightforward answer. That requires a lot of understanding of not only your needs, but what Industry 4.0 can deliver as well. So this is the fact why I have categorized 3 sections as our agenda items for today. So first and foremost, I will talk to you about the technologies that make up Industry 4.0. And then I will talk to you about some established business models. Now, this business models aspect is something that I assume that manufacturers are more commonly aware of. The reason being the fact that they have been in existence for decades and they have been utilized in the manufacturing sector to optimize production, to reduce defects, to reduce variability, and to enhance performance. Now, one gap that I have identified through my various projects and work with companies is the fact that there is a gap when it comes to linking what these Industry 4.0 technologies can do and how managers can utilize that information and develop a roadmap that can be used in their journey towards digital transformation. And it is a big, big problem because managers typically look at managing things, which is absolutely fine. It has served them well for so many years. But the fact of the matter is this industrial revolution has come with a lot more caveats than before. So a basic understanding of what these technologies can do is beneficial so that one can establish a sound business model that can be utilized for successful implementation. So with that said, this is how I will be discussing different aspects of this webinar. So first and foremost, I will talk to you about Industry 4.0 enabling technologies and design principles. I will give you a very common example of a digital twin, which is something that Industry 4.0 has become quite famous for. Then I will talk to you about some Industry 4.0 business models. In specific, I will be talking about a European project that I'm currently working on that deals with identifying barriers to the uptake of Industry 4.0 in SMEs, that's small and medium enterprises. My focus here would be on the readiness assessment of companies, of organizations, and the return on investment that they can think they can get. This, again, one of the aspects that are quite crucial for companies. They just don't want to invest in something that will not solve a problem for them. Because one of the main things, again, with regards to Industry 4.0, no one should just try to follow the trend, try to get on the hype train and say, oh, we all have Industry 4.0 characteristics. Absolutely not. What you should be looking at, thank you very much for that, Prasad. What you should be looking at is the fact that can you solve a problem in your business with Industry 4.0? That's the main thing. There is no need to get on the hype train. Yes, if you start working towards developing a smart factory, if you start working towards developing cyber physical systems, then yes, the sooner you start, the better, but it requires a long-term planning and a long-term goal achievement as to how you can get there. Again, these aspects I will discuss when we reach section number 2. And obviously the last section is with regards to the implementation of Industry 4.0. This is something that I have proposed and I have published as well. I am currently dealing with a few companies that might be interested in going through these methodologies, and they are based on Lean Six Sigma methodologies. Again, something that I have identified as manufacturing organizations being quite aware of, because as I said earlier, they have been utilizing this. So it reduces a little bit of that uncertainty, that unfamiliarity aspect that comes with new things that come their way. It also reduces the effect of resistance to change, because again, that is one of the key challenges that companies face whenever they try to introduce something new, something different, something that is out of the norm. They face a lot of resistance from the workforce. Even if that is for the benefit of the company, changing people is quite difficult, and there is a plethora of literature on that. How should you manage change? How should you incorporate change within your organization? And I will also be talking about how the change management that we all know and love should change as well, because it is no longer a project with a specific start, middle, and end. With digital transformation, you are looking at a much higher, a much rapid rate of new things coming in, and people need to change on the fly, on the go, in order to stay up to date with the business and in order for them to be able to contribute towards the development of the business. So with that said, let's start off with the section number 1, that is Industry 4.0 technologies. So as I have already highlighted, even to this date, there is no specified or agreed definition of Industry 4.0. But some of the factors or some of the aspects that we all agree upon, then those are related to the fact that Industry 4.0 is characterized by cyber physical systems, digital twins, automation, data exchange, the internet, digitalization, digitization. Now there's a difference between digitization and digitalization. Digitization refers to just the data being transferred into a digital format so that you don't have to deal with a lot of that uncertainty. And digitalization is a much more holistic approach where you are looking at the organizational structure and how you can incorporate all the Industry 4.0 aspects within an organization. So one more thing that researchers tend to agree on are the pillars of Industry 4.0, and they are identified as 9 pillars. And just to highlight the fact that these pillars are nothing new, so to speak. When I say nothing new, what I mean is these technologies have been in existence for quite some time. For example, the very first one that we have, additive manufacturing, the very first additive manufacturing system was commercialized in the year 1987. So that's like more than 3 decades ago. And even to this day, this technology is making an impact on our lives. And I don't think I have to go into much details about additive manufacturing. The reason I say that is because I'm sure everybody is aware of the response that the additive manufacturing community has provided to the medical professionals by quickly and rapidly developing face masks, face shields, ventilator valves, door openers, hands-free door openers, and all of those things that the additive manufacturing processes are producing and providing to our medical professionals so that they can combat COVID-19. In totality, additive manufacturing is characterized by 7 categories. So all of these categories, as you can see on the screen, I'm not going to bore you with the details, but all of these categories tend to add something to the mix. All of these technologies work on the same principle by adding layers on top of layers. But the difference lies in how they add those layers. So one recent development that I would like to share with you is this dress right here that you see on the screen. So this is known as a proximity dress that has been 3D printed. I'm sure there will be new styles coming. Currently, there is only one dress that you see on the screen. So what it does is it is incorporated with sensors and actuators. So upon recognizing the social distance parameters that we have to abide by according to the UK government regulations right now, you can very easily identify when you are invading somebody's personal space or somebody's social space. So that gives you an indication that, okay, it is time to back off and not go into somebody else's social space that might increase the risk of the spread of COVID-19. So again, a very useful thing that has been developed. And this is one of the main features of additive manufacturing. It allows you the freedom of design. You can pretty much design anything as long as you can make a 3D CAD file of it. It gives you the freedom of choosing different materials that you can utilize. It is very rapid and allows you to manufacture different products and reduces the lead time from design stage to the production stage. As I said, I mean, the additive manufacturing is one technology that I don't think that I have to go into much details because we have all seen the impact that it has on our lives. And one aspect that I would like to highlight here, and something that I have been researching on as well, is owing to this current situation with COVID-19, I think that there is a need to establish a network for additive manufacturing as well. So all the additive manufacturing market leaders need to come together to make sure that they can still share the designs, the production methodologies, the parameters for good printing and whatnot with everyone, so that this can benefit the community as a whole. Because right now, one of the main reasons why we have been able to respond to COVID-19 at such rapid rate is because there is a digital sharing practice in place where designers are in contact with manufacturers who are in contact with the medical professionals. So this chain, this digital link is working very well. And we need to establish this link even further if, God forbid, we are faced with a second wave or even something much worse down the line. So with that, let's move on to augmented reality. Again, one of those technologies that is gaining a lot of momentum, a lot of steam, mostly owing to the fact that you can augment a 3D object in your own physical space and you can play around with it. For example, what you see on the screen is this gentleman is currently looking at different aspects of an exploration site where he doesn't need to be there physically, but he can still look at all the different aspects that are there. Augmented reality helps a lot when it comes to training new employees, when it comes to enhancing their capabilities. Research has shown that the performance of employees increase drastically if they are developed through augmented reality. They help to optimize even the production flow. And these are quite fondly used in industry with the use of some hardware. And there is a specific example that I will be going through towards the second section of the presentation. The combination of augmented reality with virtual reality adds a little bit more applications to the mix. So now, in addition to having a 3D augmented version of something in the physical space, you can enter a virtual space as well. And these technologies are making quite a lot of difference when it comes to industries, and specifically with regards to assembly operations, because if you can augment different aspects of the assembly operation, you can do that fairly quickly. On top of that, analyzing the different aspects of a machine or a system. For example, the figure number 1 on the left-hand side that you can see, this is right here where augmented reality has been used for maintenance operations. So it shows you if there are any issues with your current system, with your current product or your process, and it gives you details of how you should go about that. So imagine if it's late at night, the production is running, and you have a new operator on the production floor and he doesn't know how to do X, Y, or Z. These directions would be very, very helpful and would avoid a serious disruption in your production flow. So this is, one of the aspects of augmented reality. Then let's move on to the third pillar, which is simulation. Again, something that has been used in engineering for the last few decades, I would say. What simulation does is it creates a virtual environment where you can actually see how your product or how your process would behave under different conditions, under different aspects of boundary conditions that you can apply. For example, what you see on the screen is right now I am heating product between 2 heating plates. One of the heating plate is on and the other is off. And you can see the temperature distribution with time as the simulation runs. So these are very, very helpful because sometimes, even if we run an experiment, sometimes there are certain aspects that are hidden from us, from the naked eye, or from even an experienced observer. And these simulations allow you to go into every creak, every aspect of your product or your process, and allow you to identify problems that you might oversee in a simulation. So they are very, very useful tool. But one thing we need to be careful of when we talk about simulation is the fact that these simulations should always be validated. So there should always be an experiment accompanying a simulation to make sure that the difference in the simulation results and the experimental results are within acceptable range. Because without that, you can simulate pretty much anything and you will pretty much get a result out of anything. But there is a saying that we use quite a lot when it comes to simulation, and that is garbage in, garbage out. So you want to avoid that scenario, and you should always, as I said, validate your simulations through experiments. So all of these work that I'm showing you, they are my work and they have been validated through experiments. So this right here is a simulation where I will run the simulation, but let me just give you a brief idea of what it is that I'm trying to do here. So in this case, I have a container. The container has water inside of it. And this white thing that you see in the middle, this is a device. This device, I want to know whether this device will stay at a constant temperature because this is needed for a specific application. So one way that I have identified of making sure that I can get that uniform temperature is by pushing a stream of cold water from the bottom side of my container. So if you focus on the right-hand side, the bottom side will be sprayed with a stream of cold water. And on the left-hand side, you can see the temperature changes as that stream fills through my already available liquid in the container. And on the right-hand side, you will be able to see the velocity magnitude as that stream continues to run. So let me just play this, and I want you to observe how these contours change and how you can identify exactly what is happening at any given time, so you can make an informed decision how to go about with your experiment. So as you can see, the stream is starting from the bottom, and as it is doing that, on the left-hand side, you can see the temperature coming down. The red aspect is the high temperature, and again, with the velocity contours, you can see the different temperature changes. So now the device that is in the middle, that is what I want at constant temperature, and that is what I can get running a simulation for a few seconds. So this gives me the confidence that yes, my idea is correct. Now I can move on to the next phase, which is validating this simulation that I have just run to ensure that yes, I am on the right track. So it is a very useful tool when we talk about product development or product optimization. And not just that, I mean, the products are what we are talking about, but obviously there are manufacturing processes out there as well that needs optimization. So again, there are a number of software packages out there. This right here, what you see on the screen, has been modeled in a software called Witness Horizon. There are tons more out there, Simul8, SimpliFact, and a lot of them that you can utilize, and they all pretty much work on the same principles of mathematical calculations that allow you to get to the finish line. So what you will see in this simulation is there's a product that is being manufactured, and as you can see at the bottom, you will be able to see the finished valve is the product that is being manufactured, the finished number of products as they are developed through this production flow. So by using this simulation, you can identify bottlenecks in your production flow. You can optimize your resources to ensure that you get the best results out of it. And you can even identify if there are any blockages, or if you're designing a new facility, you can work around with this so that even before going to the physical implementation, you will have a virtual model that will tell you exactly what you need to do. You can play around with different scenarios, different operating parameters, and at the end of the day, you can come up with the most optimized version of what you want in your facilities, and that will save you time, money, and resources. So let's have a look at this simulation right here. So as time go by, you will see that around the 180 mark at the bottom of the screen, we will be getting one product finished. So the production flow, as you can see on the hardener from the staging area, the product is moving from the first stage, which is where it was received as a metal bar with raw material. And as it went through different iterations, it allowed us to identify how the process is going, what do we need to change, and how can we get the best out of our production flow. Right, so moving on, we have autonomous robots. Again, as I said, these are not new technologies. We all are quite familiar with robots, and we have been using them in companies for decades now. Autonomous robots add a little bit more to it. What that does is it allows the robots to be more self-aware. They should be able to self-configure, and this will allow a level of autonomy to the robot, so that humans should only be working as supervisors and not necessarily be on the production floor doing these operations. There's another class of robots that has popped up, which is again making a huge difference to the industrial sector, and those are known as cobots, or collaborative robots. What they do is they augment the human capabilities that humans can do in their own physical limits. So humans can be working with a robot on the same product, or they can be used by humans. For example, an exoskeleton is a prime example of that allows humans to lift more than they are capable of in terms of weight. So these cobots, they allow humans to do more, to be more. An automated guided vehicle, again, is a very good example of that. And notwithstanding the inherent advantages of robots, like increased productivity, increased performance, all of these just get added together with these cobots, and we can do now quite a lot more with these autonomous robots as we could have done in the past. So the next one on the list is Internet of Things. Now you might be thinking that even to this point, the four that I have just discussed, they seem a bit scattered. They seem like one thing and the other and the other. Now these four that I'm about to talk about, they are very much, or they should be very much in conjunction with each other, because they complement each other very well. Now, it is not to say that we cannot incorporate the other four that I had just discussed. It is just a matter of finding what fits within your organization. This is what I said. It is not a one shoe fit all kind of a scenario. So you need to pick and choose what you want and how that will impact your business. So as far as the Internet of Things is concerned, now this is with regards to the interconnectivity of our usage, the interconnectivity of different systems, different devices, different machines, and that data that we collect from these machines, the interaction with humans, that all is encompassed within the Internet of Things. Its use in manufacturing is termed as industrial Internet of Things. So it allows you to do quite a lot, and it allows you to be able to get to the point where you can utilize that and you can get a lot of benefits out of it. So one of the main aspects of Internet of Things is collecting data. When you connect a number of sensors with your existing system, for example, let's take a very simple example. This is one of the examples that has been utilized as actually a hallmark of Internet of Things, where legacy systems have been transformed into digital systems. There was an example with regards to a CNC machine, a very old CNC machine, and a lot of different aspects were added to it. A lot of different sensors were added to it. So imagine your CNC machine having this 5 sensors and you attach 10 more sensors to it. Now the data stream has increased drastically. What can you do with all of this data? That is the main concern that you should be having, because number one, you're not familiar with this data, and number two, you don't know how to use this data to make informed decisions. This is exactly where big data analytics come in. Imagine collecting all of this data from all of these different sensors and trying to make sense of that data. Big data analytics allow you to do that. It gathers the data, it analyzes it, it transforms it into a form that is understandable to you. It makes sense of the data so that you can make informed decisions using it. So in terms of data, we have 4 different types of data sets that generally gets developed. Number one is structured data, then semi-structured data, quasi-structured data, and unstructured data. And as you can see from the graph on the screen, the more we work with are the structured data. But the unstructured data is increasing in growth as we speak. Why? Because as I said, now we have way too many sensors and we don't really know what to do with all of that data. And making sense of the unstructured data is one of the most difficult things to do. And big data analytics allow us to do all of that. So what exactly do we need to do with this data? I mean, it is a good thing to have data. I would like to know much more about the Bollywood actresses and the Bollywood actors and which new movie is about to come. But what exactly am I supposed to do with that data? Am I supposed to plan my next weekend to go and watch that new movie? Or am I supposed to just keep up to date with that information? So it is all about making decisions. So what big data analytics allows you to do, it allows you to look at 4 different types of analytics. Number one, it gives you descriptive analytics. What is happening within my business? It is a very useful thing to have. And sometimes at the top level, at the senior management level, the shop floor or the operational floor intricacies can be overlooked, but the analytics, the big data analytics does not allow that to happen. So it provides you with descriptive analytics. It provides you with diagnostic analytics. Why is it happening the way it is happening? Why are things going wrong? Why the last 2 weeks my production did not reach my planned mark? Why has something gone wrong? So these diagnostic analytics are very important so that we can identify where the problem is and we can solve that problem to make sure that it doesn't happen again. Predictive analysis, we have been using this for decades. I mean, how do you think the weather people tell us it should be 28 degrees outside, or it should rain the day after tomorrow? That is all predictive analytics. And last but not least is prescriptive analytics. What do I need to do? If by running, let's say, simulations, if by attaching a lot of sensors and getting a lot of data, I find out that after 50 more runs, my product will fatigue and it will crack under the load that is being applied to it. What can I do now? This is where prescriptive analytics come into play, and you can very easily utilize all of this data, all of these analytics to make informed decisions. We now in this day and age are much more informed than we were even 5 years ago. So this is the time to take advantage of these aspects and be much more skillful and mindful of how we incorporate changes and where should we invest in terms of our time and our resources. So again, with big data analytics, we then move on to cloud computing. So I'm sure by now you would have gotten a sense of what is actually happening. We are only talking about technologies that are digital in nature. When I say digital in nature, they mostly deal with the internet or a digital format of working, and that is the hallmark of Industry 4.0. So why exactly do we need cloud computing, you might ask? Well, imagine having all of that big data sets coming your way through the Internet of Things, and the big data analytics trying to crunch those numbers, trying to give you the best analytics that it possibly can. Now, I'm sure you would understand crunching those numbers, running those analytics require a very, very sophisticated system. So imagine buying a 50,000 pound computer that can run such software packages that can show you such analytics in a timely manner, mind you. I mean, there's no point getting the analytics after 3 days when the problem occurred on day 1, and 2 days you are simply waiting for the analytics to finish. That will not serve you any good now, will it? So this is where cloud computing can help. Cloud computing allows different subscription services where you do not need to buy expensive hardware, and all of that computing, all of that number crunching can happen on the cloud. So it allows you to save time. It allows you to save money on hardware upfront in terms of capital cost, and different cloud subscription services are available that can be utilized for a private cloud, as you can see on the screen. So it can be used by an individual. It could be a public cloud that can be used by an organization, or it could be a hybrid cloud that can be used by both parties. So again, these services are, they can be subscription based, they can be pay as you go. They allow you a lot more flexibility, and they allow you not to invest too much, because imagine if you are a small or a medium enterprise, you might not have that much cash to throw around on such things, but a large corporation can get all the benefits of cloud computing fairly easily. So this is one way of alleviating those issues, where you can incorporate cloud computing in your system, and if you don't need it for the rest of the year, you can simply cancel your subscription. If you only need it for a specific time, for a specific duration, you can do all of those aspects through cloud computing, and it allows you to do all of that. So again, combining Internet of Things, big data analytics, and cloud computing. And since we are talking about digital stuff now way too much, cybersecurity cannot be overlooked. This is why it is one of the pillars of Industry 4.0. Imagine getting all of this data with all the information in the world that you can think of: personal information, product information, process information, your new plans, what do you intend to do in 5 years' time, all of that. Imagine if it gets hacked. Imagine if somebody holds you at ransom to give you X amount of money so that they do not leak your information to the world. And I'm sure we are all aware of all the scandals that have come about that. The scandal of when Facebook had lost all that personal data, and when some emails got leaked from Hollywood executives, and in the candidate race between Donald Trump and Hillary Clinton. Don't want to go into those details, but my point is cybersecurity is a very, very crucial part of Industry 4.0. You need to be able to protect all of this data that you are generating to make informed decisions, to have a good control, a good solid control onto your systems, and all of this is done through cybersecurity. Right, so this brings us to the last pillar of Industry 4.0, which is horizontal and vertical integration. And this is precisely why I wanted you manufacturers, you people working in the manufacturing sector to understand what these technologies are, so that when you reach towards the horizontal and vertical integration, you would be able to understand and appreciate their implementation. So the aim of the horizontal and vertical integration is to develop organization-wide protocols for data sharing to create the basis for an automated supply and value chain. This is the ultimate goal of Industry 4.0, to allow you, to give you the freedom and the flexibility to be able to integrate all of these different aspects within your factory, within your organization, so that you will have all of these advantages at your fingertips, and you don't have to do an analytics, you don't have to do analysis every now and then to come up with a new system, come up with a new design. All of these things, they go hand in hand, and when they do, we move on to something that is known as a smart factory. Again, that is just an idea that is being floating around, and I will show you some examples in a few minutes that you will understand why these are just ideas and not applied on a much larger scale. So this is with regards to the 9 pillars of Industry 4.0. Again, I'm sure you can find a lot more different aspects to it. You can find stuff about artificial intelligence, machine learning, and all of those different things associated with Industry 4.0. But I just wanted to give you a flavor, not bore you to death with all of this. So with regards to Industry 4.0, as I said, this is one of the most agreed upon aspects of Industry 4.0, the 9 pillars. Then also, it is very critical for people trying to implement Industry 4.0 to understand some design principles. Why do they need to understand such design principles? Is so that they can realize the full benefits of Industry 4.0. So these design principles should always be at the back of the mind when you are moving towards transformation to Industry 4.0. So what these design principles are, they are basically aspects that you need to understand, so that when you're implementing different technologies, you can make sure that you receive X at the end of the day. So with regards to that, let's start off with the very first one, which is interoperability, or interconnection as it is called. So it is all about the exchange of data and nothing else. Interoperability is all about the exchange of data among different systems and the different enabling technologies of Industry 4.0. If you can establish that link within your organization, you have achieved this design principle. And not only that, you should strive to achieve a design principle, but it allows you to get the most benefits out of your system. So imagine you putting a lot of these sensors on a lot of different production equipment, and not having a link to the planning people, or to the maintenance people, or to the supply chain to know what is happening on the shop floor. If you do not have that link, if you do not have that connection, you will always be compartmentalizing different aspects, and you might even be prioritizing different aspects of your organization. And that could be a bad thing in the long run. So this interconnectivity, this exchange of data among different systems, different departments of your organization, is a crucial aspect of the design principles. Number 2 is virtualization. And again, I don't think that I have to talk too much about that. COVID-19 has proved it very, very beneficial to have virtualization. So what it actually responds to is the fact that we need to be able to create systems that can be operated virtually. We don't need to be physically present to work with them. A digital twin is a prime example of that. I will be discussing it in a few slides now. A cyber physical system, again, goes with the same aspect. You will create a digital replica of your physical asset, and you can work with that. That digital replica can control your physical asset, can monitor your physical asset, and can also do analytics, run simulations, and all of those things in a virtual world. With regards to the COVID-19 aspects, some new initiatives that have been established, they are to do with creating a virtual environment for these sort of webinars, or the conferences that take place. So they will create a virtual environment where you can actually walk through a hall, you can sit on a seat, and you can do all of those different aspects. It is a very common with gamers. There are a lot of games out there that work on virtual reality, and it is slowly creeping its way into the manufacturing organizations as well. I mean, imagine walking in a virtual environment through a factory that is in Brazil or in Canada or Denmark or whatnot, and being able to see every single thing that anybody in attendance, that anybody that is physically present can see. It is a luxury to have. Then you move on to decentralization. Again, this is one aspect that manufacturers especially are considering for quite some time now, and this is to do with having decentralized operations, not have everything that you do in one singular factory. What it does is it allows you to be more flexible. It allows you to create different products at different rates for different customers. I mean, take the example of what additive manufacturing is currently doing. In this case, yes, all our focus is on face shields and face masks, but different companies, different manufacturers have started manufacturing those different products, and they are doing it in different locations. And this is why we have been able to meet the demand when it comes to these face masks or these face shields, because now a lot more equipment is involved in manufacturing such products. Then we move on to real-time capability. Again, going back to the same thing of Internet of Things and big data analytics. What is all of that analytics good for if it is not done in real time? There is no point gathering all of this copious amounts of data and not being able to work with it, not being able to process it, or not being able to have any useful information out of it. All of this needs to happen in real time so that you can actually work with these different aspects and you can get the information that you need. Then we move on to service orientation. Again, just as real-time capability, it is one of the things that we desperately need. And it is something that manufacturing organizations are finding actually quite useful. Again, look at the example of additive manufacturing. We are working with a few products, and those few products are being manufactured by pretty much every large or even small manufacturing organization all across the world. So what is happening in that regard is now organization, in addition to selling their products, can also sell their services. So it adds a little bit more profit margin to the companies, and companies can now use this model and work with regards to it. Obviously, they would have to adjust their profit margins, but how much they should get from their products and how much should they get from their services. But again, something that organizations are quite looking forward to. Next thing is modularity. I mean, not just in terms of having a system that is modular. Modularity refers to the fact that you can add or remove aspects, add or remove parts of your system as you see fit. Imagine having a Lego robot, and removing 4 blocks of Lego will make it into a mobile robot, or adding 10 blocks of Lego will make it into a truck. So having that sort of modularity, having that sort of flexibility will give you the advantages that you can't even imagine. And these advantages will only work when they are combined with these digital aspects of Industry 4.0 so that you can get all the benefits out of it. So this is with regards to the design principle. As I said, we need to make sure that they are there, they are in our plan, they are in our strategies, so that when we go towards applying or implementing Industry 4.0, we can actually achieve them and get the most out of our Industry 4.0 implementation. So this moves us pretty nicely to digital twin, which, as I said, is very, very useful aspect of Industry 4.0. So as the terminology go, a digital twin, it is simply a digital replica of a physical asset. Now, some people find this terminology a bit confusing, because in their mind, if it is just a digital replica, why can't it just be a CAD file? And it is right and wrong to a certain extent, but depending upon who you listen to, there is a slight confusion. But from your standpoint, what you need to understand is a digital twin, when we talk about it in its holistic sense, we are talking about a digital twin having a mechanistic model, a sensing and control model, a big data analytics model, a machine learning model. All of these aspects need to go together for it to be called a digital twin. Just a virtual replica or a digital replica cannot be ascribed as a digital twin. So with regards to that, let me give you a very useful example that one company, ANSYS is a large corporation that develops the ANSYS software that is mostly used for engineering simulations. So what they did was they combined with a company. The company wanted them to create a digital twin for their configurable safety relays. Now, I will walk you through this process so that you can understand how they went about doing it and what is the benefit that they got out of it. So for a digital twin to be successful, for it to work to the company's benefit, people need to understand what is it that we want out of this digital twin at the end of the day. So with regards to that, the configurable safety relays that the company uses, they are there to prevent injuries. If there is any issue in the company or any damage on the factory floor with the automation, and it simply cuts off the electric power so that the damage cannot be extended. So the problem is when this safety relay failed, the entire production line needs to be stopped. Why? Because of health and safety. You can't really put people's health and safety under risk. So this is the main problem. We need to avoid that stopping, that loss of production because of the safety relay fail, and we can't really predict when it will fail. So this is why we need Industry 4.0 technologies to make sense of why it fails, when it could fail, and how we can avoid long downtimes. So by integrating real-time sensor data with simulations to predict failures in advance, you can do that quite easily, and this is primarily what simulations are useful for. So now you can replace the relay without any problems because you know, according to your simulated data, when it will fail. So when the next time you are running a maintenance operation or there is another activity going on, you can simply go on, replace the relay, and it will not cause any problems when it comes time for your production. So what ANSYS, the company, does is they ran simulation. They ran a Maxwell simulation to show the magnetic field at different armature positions. So that allowed them to gauge when or after how many cycles will the relay tend to fail. And based on that data, they created a digital twin so that in real time, they can look at all the different aspects that are coming into the system. And at the end of the day, they know exactly when something can go wrong. And as I said, in their next maintenance run or in their next activity where the production line is not in use, if it is closer to the date that it is supposed to go out of commission, you can simply replace it and you will not have to worry too much about that. But in doing that, look at this image that is on your screen. In doing that, this is the amount of work that goes into actually developing a digital twin that is useful for you. Because again, if the phrase that I used earlier with simulations, garbage in, garbage out, you can very easily create a digital twin of pretty much anything. But if you do not have the control aspect of that embedded within your system, that system will not be able to tell you how the system is going to work. That is why for the digital relay, we need to have all the different aspects that make the functionality of the configurable relay in real time. So this is a very, very huge undertaking, and it is not a simple task, but again, the benefits are astronomical. These digital twins, they are being used quite widely these days. I mean, prime examples are in wind turbines. They are used quite a lot to make those digital twins. For motors, again, a very, very useful application. For pumps, most of these digital twins, they tend to be component based. Why? Because, I mean, as you can see on the screen, it is quite a complex and complicated thing to do. So component-based digital twins tends to be simpler to develop. Obviously, a system-based digital twin that will incorporate, let's say, 10 different machines with all the different control elements within it would be a very huge task. But it is not to say that one should not go for a component-based digital twin, because if the component that you are currently developing a digital twin for is the most critical part within your system, then it is a wise thing to do so. If it is the most critical part that can stop your production or that can hinder the production flow, then it is something that you should really be looking towards creating a digital twin, so that the chances of it happening in the future again and again, over and over, can be reduced as much as possible. So that is an example of a digital twin. Now, as I said to you earlier, I will also be showing you some details that are available with regards to what Industry 4.0 has developed. So MTC, the Manufacturing Technology Center from the UK, they have actually developed a factory in a box, as they like to call it. And as you can see at the bottom of the screen, this factory in a box is basically in a room where they have used a number of digital technologies that can show us how different aspects can work together. You can configure it to different production flows. You can configure it to based on your requirements. And what you see on the top screen is a virtual environment where everything that is happening in the real world can be seen in the virtual world. So it allows you to get a good understanding of how these things will work. So this is a very useful thing that has been developed, and it allows companies to test their models. It allows companies to just have a understanding of how they can incorporate different digital technologies, because seeing something in the real world is much more impactful than simply somebody explaining you that, oh, if you add this and this, you will get X. So this is, I mean, a very useful thing that has been developed, and it is making quite an impact in the real world. So another thing that has been established by Germany. I mean, Germany is one of the leaders when it comes to Industry 4.0. In fact, they are the ones who has the most discussions or most documents generated for Industry 4.0, and it is known as the DFKI Smart Lego Factory. So in addition to having all the different aspects of Industry 4.0, it also shows you a production line. It shows you the production line. It is, I mean, made out of Lego bricks. So that also piques some people's interest. This production line is used to build tractors, and the assembly line is fully monitored. And one good aspect of this smart factory is the fact that it allows you to actually monitor and derive key performance indicators right there on the software. So in addition to working with all the physical aspects and the digital technologies, now you can combine them all together, and you can analyze, visualize, and identify different aspects, different key performance indicators that you can utilize for best practices. Even in your own production flow, you can manage that within the system, and it will give you the same kind of output depending upon your requirements. So this was, I mean, very briefly, I tried to be as brief as I can, because obviously this is quite a huge topic, and quite a lot of, as I said, gap is present when it comes to understanding these technologies and what they can do. So now once we understand what these technologies can do, now let's have a look at some Industry 4.0 business models. So there is one project that I alluded to earlier that I'm currently working on, and it is a European funded project. It is worth 3.4 or 3.6, I think, million euros and whatnot. So it is to do with identifying the barriers to the uptake of Industry 4.0 in SMEs, that is small and medium enterprises, and propose different management related tools for ease of transformation. It is called Growing into Industry 4.0. You are more than welcome to have a look at the website that is shown at the bottom of the screen. So what we have done for this project is we have developed different tools that SMEs can utilize. They include readiness assessment, return on investment, and benefits realization. some of the benefit realization can be done within a return on investment, which I will discuss in a few minutes. So what these tools are useful for, number one, they allow company and organization to understand where do they stand with regards to Industry 4.0. Are they ready to go there? Are they like the worst of the lot? Are they somewhat there? So these readiness assessment aspects are very useful. Let me give you some common example of readiness assessment tools that are already well established and are out there. They include Impulse, that is again generated by Germany, in then partnership in the UK. Developed another tool, PwC self-assessment tool, again generated by a UK company. Industry4.0 is generated by the Ministry of Malaysia. So these readiness assessment tools, what they do is, in addition to the technological burden, they look at the entire organization and how can the organization come together in realizing the benefits of Industry 4.0. So that is the main aspect of it. It's not just that, okay, additive manufacturing, do you have additive manufacturing? Yes, no, yes. How much do you work with it? About 10%. Okay, well, you can't do Industry 4.0. It is not like that. It is not as cut and dry. So let me show you an example of the Impulse tool that has been in use for quite some time. It is quite a comprehensive tool. And as you can see on the screen, it has been defined into 5 categories. So you have strategy and organization, that again is subdivided into some domains that you can look into: smart factory, smart operations, smart products, data-driven services, and employees. Again, this is one of the most critical aspects that you can think about when it comes to Industry 4.0 transformation. Employees, their skill sets, their skills acquisition, that is the most important thing. And also, of course, managing change that comes with it. So as I said, these self-assessment tools allow you to assess your own organization, and they are available online. You are more than welcome to go and have a look at that. The links are here on the screen. You can go there, you can fill in a questionnaire. Different questions will be asked based on these categories and these subdomains. And then at the end of it all, when you are done with the questionnaire, you will be given an understanding of where do you stand with regards to your own Industry 4.0 readiness. Are you ready for that? If you are not ready, if, for example, your answers have specified that, then it will give you a level of 0, which is, sorry, level O, whatever you want to call it, of an outsider, which would mean that you are a newcomer or a beginner. So level 1 would put you at a beginner level, level 2 will put you at an intermediate level, and so on and so forth. So it is a very useful thing to gauge where do you stand and where do you need to go. And it also allows you to benchmark yourself against other SMEs or other companies out there in the market. And this is where this PwC self-assessment tool comes in. This PwC is a multinational company that has developed this tool. And again, it does the same thing as the previous one, albeit a bit differently. So it again looks at these different categories, and within these categories, you can be identified either as a digital novice or a digital champion, depending upon how much or to what extent you are making use of digital technologies. So as I said, these self-assessment tools are very useful to assess where your company is with regards to the world and where it needs to go. So it gives you a very good gauging mechanism. For example, what does a digital novice look like and what does a digital champion look like? So you can very easily select on a scale of 1 to 5 for that to happen. Right, so now I would like to talk to you about return on investment, and this is something that I have been personally looking at myself. Again, with regards to Industry 4.0 tools, as I said, there aren't that many standardized approaches out there. So a lot of it is to do with either modifying existing tools or developing completely new tools that have some basis on existing tools. So what I had done for the European project that I mentioned to you a few minutes ago, I made use of Phillips ROI methodology. Again, this is a methodology that exists in literature. This was developed back in the 1990s, and it is still working to this day and doing quite well, having been practiced in a lot of countries and even continents for that matter. So it has 10 different steps that need to go into, and these steps are divided into 4 phases. I will not go into the details of all of that, but I will focus on one thing in particular that I have identified that companies find it very, very challenging to do. And that is to convert data to monetary value. So what does that mean is there was a company that I did this testing with, and the way I would do the testing is I would ask them a series of standard questions so that I can understand their business and understand where the limitations are, what do they want to do in terms of optimizing their performance, or how exactly do they intend to go about doing that. And then I would propose some Industry 4.0 related technologies or protocols that they can utilize to increase their output. So one of the companies that I did this for, it was a company that was assembling a product in their facilities. So what I asked them was, okay, tell me, how do you think you can improve your production, or is improving production a main objective for you? And they said, yes, absolutely. I said, okay, so how do you see your production improving? They said that, well, if we can assemble more products in a unit time, our production will go up and our profits will go up. I said, fantastic. And then I asked them that, okay, and this is the most important thing. When we talk about SMEs, even the large corporations, getting that data, that useful data is very, very critical. Why? Because now when I asked them to get the data and tell me how much do they make on average, there was some trepidation, there was a hesitation that, okay, what if this is not what you want? I know that you asked for X, but this is not that X completely. Why? Because we never really collected that data. And that is one of the most important things that you need to understand when you are thinking about digital transformation, is you need to put resources in place to collect data before you start with the implementation, because you need data to make informed decisions. The example that I gave you with big data analytics can't give you anything if you do not give it an input of data, and that data has to be in abundance. That is why it's called big data, which means that these are extremely, extremely large data sets. So imagine you not providing with the sufficient data to work or to make a decision, then whatever return on investment calculations you do will not be realistic. You will still get an answer. I mean, again, going back to the same thing as simulation, you will still get an answer, but that answer will not be realistic. It will just be something that you have calculated. So based on that, I mean, I worked with them. I proposed to them that how about you incorporate augmented reality within your premises and get your new people who are coming in trained through augmented reality, your older people who are currently working on it, make them use that new technology, because the research has shown that it can increase performance quite drastically, and it can also reduce errors quite drastically. So it is a very worthwhile investment. So what they did was they provided me with some data, and based on that, they simply gave me a ballpark figure, and they said that, well, we think our benefits would be somewhere in the range of £120,000. I said, okay. So that is a ballpark figure that they gave me. I don't know how much data they collected. I don't know how did they come up with this number, but this is what I got. And this is the most critical aspect of this calculation. I mean, a return on investment calculation is not rocket science. It's a very, very simple one number divided by the other aspect, but it gives you a good indication of where you are going with your money. So when it comes time to doing the costing, I mean, I'm pretty certain a lot of people can do the costing side quite easily. They know how much something costs. They know how much things need to be, or how much needs to be put in. But when it comes time to the benefits, then they have a problem. So based on that, what an augmented reality can do for you, I looked at a proprietary software package and some hardware training for the individuals, and I told them that, well, this is how much it is going to cost. So based on that, I mean, I got the total for the cost, I got the total for the benefits. As I said, the calculations are extremely straightforward. If I were to calculate a benefit to cost ratio, I will simply divide the benefits with the cost, and I will get a 3.15 to 1 ratio, which means that for every pound invested, there will be a 3.15 pounds in benefits. Same goes for ROI and payback period. Very straightforward calculations. But the critical thing, as I said, is the fact that the benefits need to be realistic, and they need to be based on data that is collected in real time and analyzed properly. So one way I would suggest something like this should work is by having a much more systematic breakdown. For example, improvements in profit due to reduction of assembly time. That is something that we can very easily quantify. Error reductions, how much error have you reduced? If, for example, on average, 2 of your products cannot pass the quality inspection, will that change if you incorporate any of those things? How much time savings do you expect to happen? Now, for that, you need to add the fact that there will not be 2 products failing quality inspection anymore. And because you are now working in an augmented reality version, you would be able to save time quite a lot. It will obviously increase performance. So now your people will not be as fatigued as they were before. It would involve faster learning for existing and new workers. Again, all of these aspects need to be understood, and they need to be incorporated within the benefits calculations. And again, companies typically don't put in resources to capitalize on their intangible benefits, but if you incorporate something like augmented reality, you are looking at higher employee satisfaction, you are looking at reduction in stress, and you are looking at better teamwork. So these things need to be acknowledged, if not quantified. They are intangible, so it is hard to quantify them, but they still needs to be acknowledged. So same goes for the cost. I mean, it needs a specific breakdown, not just with regards to the software and hardware, but the storage capacity as well. You might need a special box or a special place to put in the HoloLens or any other augmented reality device that you are using. And again, training of individuals is a very important aspect. So looking at all of these different aspects, looking at all of these different things, only then you can have a realistic calculation of return on investment. And that is the most critical thing that most companies are not comfortable with. So that was to do with some established Industry 4.0 tools that can be utilized even before we start to move towards such a transformation. Now that I have given you a brief understanding of the technologies and the established business tools of Industry 4.0, let's have a look at an Industry 4.0 implementation and what you need to be mindful. Again, as I have said many times before, this is not a one-shoe-fit-all kind of a scenario. You would have to tailor this implementation plan according to your own requirements. You might not need to do all the different aspects that are involved here, or you might want to cut short on some of the things that I will describe. But again, this is a very much a decision that you would have to make based on the requirements of your business. So this is a plan that I have introduced and proposed and published. And this is deeply rooted in Lean Six Sigma methodologies. I mean, the reason I use Lean Six Sigma is because, as I said, it will mitigate some of that resistance towards change, because manufacturing organizations have been using Lean Six Sigma protocols for decades now. So what I did was I made use of the DFSS, which is known as the Design for Six Sigma approach. And within that approach, this is typically used when one wants to go for developing a new system or a new product flow. So for that, I identified several steps: define, measure, evaluate, optimize, develop, validate, implement, and then obviously having a continuous improvement cycle using DMAIC, again, another aspect of Six Sigma. And this should lead you to digitization of your company. So let's have a look at these different aspects in more detail. So in the define stage, what you need to do is you need to define what is it that you are trying to do. And it can very simply be a business problem. It could be that, well, my business problem is I am not producing enough output. How can I mitigate that? And then you need to align that with the organizational strategies. The reason you should do that is because, as I said, resistance to change is something that you will face all throughout, especially considering the fact that in the manufacturing sector, especially in small and medium enterprises, there haven't been that much of a revolution anyways. We are still working with the same old system that we worked with 10, 20 years ago. So it is very, very crucial to make sure that the resistance to change can be minimized as much as possible. And this is not just to mitigate that aspect, it is a very useful aspect to incorporate, where you align your goal with the digital transformation with the organizational strategies to make sure that you have the support of the entire organization. The next thing that you should do is establish an appropriate team. And this team should not just comprise the senior management, but people from different departments, people who actually work on the shop floor, so that you can get the insight into how things are done. Then based on the strategies of Industry 4.0 that you are looking into incorporate, again, look at your customers. It could be one thing that you want to incorporate Industry 4.0 because this is the new thing in the market and you should go by the trend, but focus on your customers. Do your customers want it? Will your customers be able to adjust to the new changes, to everything digital? Imagine the customer who was always happy to see a human face come to them and deliver them their goods or a receipt that they can hold in their hand because they feel better with that. Imagine giving them everything digital, you doing a virtual call with them like I'm doing with you right now, or you simply popping up on a computer screen with them, you sending them all the receipts digitally. Will they be competent enough to work with all of that? These are some of the things that you might need to be mindful of. It is very easy to get lost in all of this Industry 4.0 technology aspect, but it is always important to be mindful of what your customer want at the end of the day, because they are the ones who are making your business run. And then obviously based on how you want to go about that and to what extent you want to incorporate Industry 4.0, you might want to modify your marketing strategy. I mean, going digital means that your marketing people would have to do quite a lot of work in making sure that the changes are seen by everybody out there. The human resource strategy, again, going back to people, managing their expectations, upskilling them, or even getting new people that have the required skills. IT maturity strategy, going digital requires a lot of IT resources. Do you have access to them, or do you intend to spend resources to get them? That is something that you need to identify. Smart manufacturing strategy, smart supply chain management strategy. If you intend to incorporate horizontal and vertical integration, this is something that you should be looking at developing anyways. So based on whatever your aspirations are, whatever your goal is, whatever small or big aspect you intend to incorporate, I would personally suggest start off small and then see how things turn out, and then slowly and gradually build up, because it is not as straightforward as taking something out of a box and just simply plugging it into a socket and voila, we have some stuff. It is a very, very complicated and a tiresome journey that organizations will have to take, and it should start with baby steps and then move on to much more comprehensive transformations. And of course, we need a change management strategy, because without that, this whole thing could very easily fall apart. So having a clear idea of what it is that we want to do, how does it fit with our organizational strategies, and what is the plan? How do we go about that? And what is the time frame? I mean, there's no point just keep doing it until we get it right. You need to specify a time frame and you need to stick by it. that is very critical in your defining stage. So when you move on to the measure stage, this is the point where a lot of different aspects come into play, especially considering of what your goals are. You might want to look at those goals, and you might want to collect data that, okay, this is currently what our practices are. If they go up by 10%, what does that mean for us? If they go by 5%, what does that mean for us? You need to identify performance metrics. You need to identify key performance indicators, measure how your system is currently running, do cost-benefit analysis, as I have already shown you before. You also might want to use some readiness assessment tools, again, that I have shown you before. If you are working with a product, you might also want to do a quality function deployment that can change or transform the voice of your customers, both internal and external, into product characteristics. So, I mean, you might be interested in developing a smart product that you can look into. So all of these things need to be measured, and this is exactly why I explained to you the benefit realization aspect, so that you can understand how do you need to measure and what do you need to measure in order for you to have data that can inform your decision-making process. Then when it comes time to evaluation, the first thing obviously you would have to do is benchmark yourself. Where do you stand? And that benchmarking can be done through the readiness assessment tools. Again, I mean, it will take you 5 to 10 minutes to complete one test, and then you can also look at your quality frequency domain. Based on that, you can generate some concepts that, okay, if this is a production flow right now, what if we change it to X? So you can have a process that already exists. You can create different designs for that, and I'm pretty certain a lot of us manufacturers do that. When I was working in the industry, we did that quite a lot, just to make sure that we get the best results out of our system. And sometimes we would focus all of our resources towards one specific product because according to our plan, we need to get that. Or for example, we received a lot more raw material on that product as opposed to the other product. So we couldn't make as much of the other, but we can make a lot of one type. So these are sort of things that we do on a regular basis anyway. So now you need to look at it in a much more holistic manner and establish some different alternative designs. If it is for a production flow, if it is a product, you need to look at these different aspects. Now, once you have developed these different aspects, these different concept designs, you might need to then narrow them down, because obviously if you talk with somebody on the production floor, that person will give you a specific design. If you talk with somebody in the maintenance department, they will give you a specific design. Not to say that they are looking at easing their workload, but it also goes to show how people look at different aspects. So it is important to have that balanced team, as I mentioned in the define phase, so that you can get the opinions of different people for different aspects. One useful tool is known as the Pew Matrix. I mean, it allows you to basically put everything side by side, look at the positives, look at the negatives, and whatever gets quantified the higher, you can utilize that to be your final design. So after the evaluate stage, you might want to move towards the optimize stage. Now the optimize stage should involve building CAD packages and developing full-scale models of whatever it is that you want to work with. If it is a product or it is a production flow, simulations is a very, very useful tool to use. And this is why I spent some time showing you some videos of simulation, both of product and production flow. So that will all allow you to optimize your system. You might also want to incorporate some lean management principles, identify some conforming standards that are beneficial to you. It could be your state standards, it could be government standards according to whatever product or process you are running. So all of these things need to be incorporated in the optimize phase to make sure that whatever you are doing will give you the best results at the least amount of resources used. So after optimize, obviously, when you have had a design, you might want to develop that, and that development should always start with a prototype. I mean, it is a good practice to mitigate the risk through prototype development. So you require the appropriate resources and skilled personnel who will help you in that development stage, identify the most economic method, and then build a prototype to validate the simulations. Then when you're validating it, you will run the prototype, you will run pilot studies, and in the prototype stage, you might want to run more than a few iterations or more than a few different conditions on your system, just to make sure that you can get the system up and running in quick succession without any problems. So this will first and foremost validate your simulations. And at this stage, you need to look at your define phase to make sure that what you have done is actually in line with your define phase, with the strategies that you had defined earlier, and you collect data for comparison. And upon comparison, you would be able to see and even show your customers, both internal and external, as to how this transformation has worked for you. And this is the stage after the prototype testing when you need to decide whether you want to scale up this design or not. The scaling up means that this would be a full-scale implementation now. It is completely your decision. As I said, you might just want to run the prototype on the side, and you might want to monitor it for a while, and that is absolutely fine. It is, again, your decision because you are the one running the business. You understand it better. The technology side can be understood by an external expert, but you understand your business better, and you need to be able to put your foot down when it comes to such decisions. You don't need to rush into this. You need to plan for this. And this is why developing a transition implementation plan should be the next thing on your agenda. You should be the one leading that charge. You should be the one developing that plan, how you will upscale this, how you will go about even just having prototypes over prototypes for your development until you are ready to integrate everything together. It is always good practice, obviously, to document operating procedures so that you can very easily change them in the future. So when it comes time to implementation, obviously, if you have decided and you are ready to implement it, you need to establish a steering board for digital implementation. Not a necessity, but it is a good thing because it will allow the people who have been working on this for quite some time to step away for a while and to observe the situation as a whole. And now you have a new set of people who can bring in more expertise. Obviously, training some digital transition champions would be good, and they should be from the original team that started this whole process, because those should be the one who should be leading the charge for this with the support of the steering board. Then you can go for a full-scale pilot run. Again, you will define your transformation. You will define the aspect that now you are in line with the defined phase. You have implemented what you set out to do. And if that is something that is in line with your goals, it is something that you wanted to achieve and you have now achieved it upon comparison and data collection, you can see that. Then you document your operating procedures and you standardize them. And this would be something that you can utilize for as long as you are running. Even if you want to make changes, you can very easily do that as time go by. So towards the end, after you have implemented everything, it is always a good practice to continuously monitor your process, to continuously look for opportunities for improvement. From the Six Sigma side, DMAIC, the define, measure, analyze, improve, and control is a very useful tool that you can utilize. Another cycle that you can use is known as the PDCA, Deming Cycle, Plan, Do, Check, Act. You can utilize, either one of them. And they are both quite structured, obviously, depending upon, as I said, how much resources you want to incorporate and how much analysis you want to do. You can look at implementing either one of them, and they will allow you to continuously improve your process so that when the next time you are looking for a big transformation, you can go back to the define phase, which I showed you earlier, and you can again go through the entire cycle as it was. So in conclusion, I would simply like to highlight the few aspects that I have been mentioning throughout this webinar is the fact that this is not a one-shoe-fit-all scenario. It is not something that you can do over a fortnight. It requires meticulous planning and careful execution so that you can implement Industry 4.0 to transform your traditional manufacturing to a digital transformative enterprise. And it will require quite a lot, ranging from technologies to business models, to skills development. Leadership is extremely important in this case. I mean, the senior management would have to step in, and they need to make sure that they manage the changes that are happening. With regards to that change management, again, the most important aspect is you need to consider this as something that will be ongoing. So people need to work on their adoption management rather than simply saying that, well, a change happened, we dealt with it, now we are done. This will be a continuous ongoing process, and people need to look into that. So, I mean, in conclusion, all I would say is I do hope that I have given you some things to think about, some important things that you can take away with you, that you can think over and utilize in your own practices towards your journey for a digitally digital manufacturing enterprise. And if you have any further questions, I would be more than happy to respond to you. Or you are more than welcome to contact me at the email address that you see on the screen. And I would like to thank you. As the questions are concerned, I see two questions here. Let me start with the first question. How far business data will be safe and protected in cyberspace? So, I mean, thank you very much for the question. I don't know whether I should mention people's name. I think I should avoid doing that. But I mean, it's a very very valid question, and this goes with the fact that cybersecurity is extremely crucial. Obviously, I'm pretty certain that when Apple started this cloud-based stuff and everybody wanted to move to Apple Cloud, there were a lot of hacks. I mean, we are all familiar of all these different things that have gone wrong over the years. And yes, this is a continuous threat to the data. But when you talk about how safe will it be, it mostly depends on how much protection you are putting in place. For example, for cybersecurity, there are international standards that have been defined to ensure that whatever protocols are being put in place, they can conform to a specific level of protection. So if you are abiding by such standards, and if you are making sure that whatever you have incorporated or implemented within your organization is up to those standards, then you might be protected from 99% of those threats. Obviously, there will always be something somewhere that is much more smart than the cybersecurity protocols that you have incorporated. But I mean, in this digital world, you can't really be certain, you can't really be sure whether this is the best thing that you can ever going to get. So yes, there is a risk, and it is being recognized by pretty much everyone, but following standards and using organizations that have established standing in the community for developing your cybersecurity protocols is a critical thing that one should be looking at. Right, so the next question is, what is component-based digital twin? I'm not clear with the example. Right, so let me give you a very simple example, Vigasha. First of all, thank you very much for the question. Let's say that we are talking about a 3D printer. Now, I know that I'm making an assumption here that everybody would be aware with a 3D printer, but let's say that there's a 3D printer, right? A 3D printer is a desktop one. It works on depositing plastic filament onto a surface, and it produces products, right? So if I were to develop a digital replica of that entire 3D printer, that would be called a system-based digital twin. When I say component-based digital twin, that means that I will only be looking at a small part of that 3D printer. So I might only want to create a digital twin of the extruder, the hot end that will extrude out the material from it. So if I only create a digital twin of that extruder, that would be called a component-based digital twin. That component-based digital twin is part of the entire system, but it is not the system itself. So that is a very useful example that I can give. I mean, and the reason I inclined towards it was because I have actually developed a digital twin, a component based digital twin for an extruder, and this example fits quite well with that. I mean, and in general, if you want to look at it, just imagine, I mean, just imagine any system that you work with. Let's talk about a coffee maker, for example. If you only want to simulate or to create a digital twin of that glass jar that heats the coffee, then that would be the glass jar would just be the component based digital twin. And if you do it for the entire coffee maker, that would be a system based digital twin. Right, let's have a look at the next question. Can we implement IIoT solutions stage-wise? Means we can decide 3 KPI first and implement it and run the prototype project. Absolutely, absolutely. I mean, this should be the wise way to go. And people should be looking at developing prototypes before going on for a full-scale implementation, because you need to mitigate risks. You need to manage risks, and there should be contingency plans in place. What if things go wrong? And considering the fact that people even to this day are not aware of how much Industry 4.0 can do, starting off with a prototype in a phased manner is a very plausible approach. Right, next question. What are the ideal milestones in chronological order for a journey towards a digital twin? Right, when we are talking about digital twin, thank you very much for the question. When we are talking about a digital twin, what we need to look into is, what do we want that digital twin to do? That is something that often gets overlooked. So if you want a digital twin to be able to control something, then you need to be able to put in those resources. So to give you the example of ANSYS, because ANSYS has released a package known as Twin Builder that allows you to create these control circuit diagrams, and they can be connected directly with the ANSYS simulation. So it is a very useful add-on that you can utilize. So what that does is it allows you to see a control system in place. So with that control system, once you have identified what is it that you want to do, for example, you want to control the temperature of something. So that temperature control needs to go in. You need to look at your system. You need to see how is your system controlling the temperature. To go back the example of a 3D printer, in a 3D printer, a PID, a potential integral derivative controller, controls the temperature. So I would need to model that PID controller within my control diagram to make sure that I can actually control that temperature. So these are the two most important things. One, what is it that you want your digital twin to do? And number two, you need to identify the control mechanisms and incorporate them. And from there, your entire process will simply flow, because once you have the control and you know what you want to do, if it is a component based, that is pretty much it. If it is system based, then you will need to do these two things for every single system that is in there. And you will need to look into every single interaction that you have within the system. Okay, so next question is, are these assessment tools global or do they give local benchmarks? Now, the two readiness assessment tools that I have shown you, they tend to provide you with a generic understanding of where you should be if you were to be a digital champion. So they will mention things like digitalized operations and control of your supply chain and all of that aspect. And they will also give you a description of what a digital Nova should look like. So it is not very much like they will tell you, okay, your company X is in comparison with company Y from Denmark. It is not like that. It is a generic description to understand what a digital champion should look like, or what a digital novice should look like. So you are benchmarking against these standardized sort of tools that have been developed. So you can see where do you stand with regards to this. What are the barriers to this journey? Well, you would have to be a bit specific. Which journey are we talking about? If we are referring to the digital transformation
Yes,
journey, then I mean,
yes,
pretty much.
Dr. Bhatt, he's referring to implementing Industry 4 in a manufacturing enterprise. What are the common barriers we may dealt with or usually
Right.
met?
Absolutely right. So I mean, in addition to this, as I mentioned, the gap between the management tools and the technologies and understanding how they mesh together, there are some commonly identified barriers that have been observed through literature and obviously through my own experiences. And the first of them go with the cost-benefit analysis, extremely difficult, as I have highlighted. The second go with change management, again, something that if not managed properly can spell catastrophe. The other aspect is skills gap analysis. Uh, One needs to understand that their workforce might not be able to cope with what is already available to them. So if they are introduced with IoT and cybersecurity and all these aspects, they might not have the skills to work with that. So it could either be your decision to fire them, which would be very uh, not a very good thing to do, or to upskill them. And this is where a few concepts that are again quite well established in literature. Work 4.0 is a framework that has been in discussion in Germany for quite some time, and that is specifically looking at what changes will come to the workforce as a result of this digital revolution. Operator 4.0 is another concept that identifies the characteristics of a smart factory operator. So these aspects should be looked into. But if I were to pick up my favorite barrier, so to speak, I would say keep your customers at the heart of your transformation. And by customers, I not only mean the external people who are paying you the money, but the internal employees as well, because they are the ones, the employees are the ones doing the job, and the customers are the one giving the money to buy those services or those products. So keep them at the heart of your transformation, and keep the human factor very close when you are defining or trying to implement any of these aspects.
So,
Well,
Doctor, yeah,
to
yes,
to a
Doctor.
certain extent, yes, to a certain extent, can it be concluded that such a technological journey has more human interfaces or aspect as some of the bigger barriers? In so many words, yes, but there are a few caveats here. The reason being the fact that it is not just about, I mean, Industry 4.0, when we talk about any new thing coming in, the humans are the ones using it. So yes, they should be at the heart of it, but it's not just the only factor. It is one of the factors, one of the most critical factors, but having an understanding of the technology and the management is also critical for the successful implementation or a successful plan for that. Yes, absolutely. I mean, I would like to thank again Prasad and OEM for organizing this webinar, and thank you very much for the attendees for taking the time out to listen to this webinar. As I said earlier, we are all dealing with COVID-19, and I hope and pray that everybody stays safe. So stay healthy, stop the spread as the